Welcome, my name is Yuka TAKAGI. I'm a student at Polytechnic of Viseu. In collaboration with Ticiana CAPRIS, Diana LOPES, Pedro Martins, Filipe and Maryam ABBASI, we made a mobile app to suggest baby names. The motivation of this project was to implement a mobile application designed to suggest baby names that are or were popular, such as extract data, analyze, and answer some questions. The goal is to provide the 5 most popular names based on a filter selected by the user. The system is composed of a mobile app device application for prospective and interested parents, and the REST API that handles the request from the application throughout the query, operations, and change to the database itself to manage the baby's name. The social benefit of this app is the ability to see the possible trending names that are available to help choose names for future babies. The system is designed to be used on mobile devices using Android and iOS operating systems. Therefore, it was chosen to develop an application using React Native, so that the application can be generated from both platforms using the same code written in JavaScript language. By exporting the data set, filtering the data, it was possible to obtain results and suggest a ranking of popular names, taking into consideration gender, name initial, state, and year. The US Social Security website is a great way to track trends in how babies born in USA are named. Data.gov publishes two useful data sets for this, one at the national level and one at the state level. Note that for privacy reasons, only the names of the babies in the same year or state are included in this data set. The goal is to extract and track information from 2 already normalized CSV files. By analyzing this data, the application will be able to answer some interesting questions, which are: what are the popular names by year, gender, state, initial of name, which will be the popular names next year. This intends to provide relevant information and suggestion to people who want names that are popular at a particular time. And this makes the name choices for the future babies. In addition, high-performance web server architecture using Node.js will be used. High performance has become an increasingly important requirement these days, given the increasing number of users that can access the platform. To maximize performance, another class of database called NoSQL databases will be used using Mongodb, document-oriented, on the client side. React Native is a JavaScript library and enabler to support mobile app development for iOS and Android. The architecture developed in this project is the Clean Architecture, which is a standard for software engineering. In this figure number 1, which is the main representation of the architecture, you can see in circles divided by layers, with some arrows going from the outermost layer to the innermost circle. The arrows show the flow and dependencies, where the outer circle can depend on the inner circle without applying the other way around. That is, for example, changes in entities that can affect all other layers of the application, but changes in drivers and frameworks are isolated from the rest of the application because there should be no dependencies between them. Clean architecture works well with domain-driven design. We'll use this notification to define application layers, which are domain, application, interface, and infrastructure. In the domain layer is the core of the software, and it brings together the main business rules for the entire enterprise. It's where the entities and values objects reside. According to Uncle Bob, an entity that can be an object with methods or can be set as data structures and functions. It doesn't matter, as long as the entity can be used by many applications across the enterprise. In the application layer contains a specific business rules. In clean architecture, Uncle Bob describes the use case as the main function of the application. These cases use entities to achieve their goals, creating dependencies on them. In the interface, where is the adapter, create adapters to isolate entities and use cases from tools, frameworks, and drivers. Used in the application, transforming data into the most suitable format for the outer layer. According to Uncle Bob, these adapters should work accordingly to concept the object-oriented programming interface in use cases as should the diagram at the bottom of the diagram above. Since there are no JavaScript interface, this can be done via dependency injection, which will be explained further. Infrastructure consists in everything that exists independently of the application, external libraries, database engines, application servers, message queues, etc. In the bottom corner of the figure 1 is an example how we can cross the boundary of the circle. The viewer, controller, and the presenter communicate with the next layer of use cases. Care must be taken with the control flows. It starts with the controller, runs through the user case, and executes on the presenter. Also pay attention to the dependencies in the source code. Each of them points to a use case. We often use the dependency inversion principle to resolve this apparent contradiction. For example, we organize interface and inheritance relationships so that the source code dependencies cross boundaries against the control flow at the right points. For example, we consider the use case requirements the invocation of a presenter. However, this invocation cannot be direct because that would violate the dependency rule. The inner circle cannot refer to any name in the outer circle. Then we have to use the case in the inner circle. We call interface. And we have the presenter in the outer circle to implement it. The same technique is used to overcome all the boundaries in this architecture. We take advantage of the dynamic polymorphism to create source code dependencies that oppose control flow, that can flow dependency rules regardless the direction of the control flow. Experimental setup. The present methodology, presented in figure 2, can be elucidated mainly by 3 layers: the presentation, application, and data. Building the entire mobile application from the database to the information processing and the actual design of the application using 3 layers, and Mongodb database, an API using a Node.js framework called Express, and mobile application powered by the React framework. Mongodb is an open source NoSQL database manager. This is used as a replacement for traditional relational databases. NoSQL databases are useful for processing large amounts of distributed data. Mongodb is a tool that can manage document information, store or retrieve information. The API for retrieving and processing data from the database is using Express, which is a Node.js web application framework and has become the standard server framework for Node.js, specifically designed for building a single-page, multi-page, hybrid web application, and is often used for making APIs because it makes it easy to develop applications that can be used to handle many types of requests. In this case, the API has a GET request that will be called front-end framework. Once called, they access Mongodb and process the database on the input and then specific request. then send it back to the application in JSON format. For easy reading, the front-end is a mobile app made with React Native, a JavaScript framework designed to write truly natively and rendered mobile apps for iOS and Android. The experimental results in this work were obtained using the following mobile hardware. During the battery performance tests, the app was programmed to be constantly performing data queries. Nevertheless, good results were obtained with regard to battery performance. iPhones were used as they were more prepared, while Android has a multitude of different devices that could interfere with nuances in hardware performance. That said, when using application, an 8-hour autonomy duration was detected when connected to a server sending and receiving requests. Results and analysis. The Baby Names app is based on a database information from the Public Social Security Administration, which tracks baby name trends in the United States every decade since 1900. The SSA published a list of 1,000 most popular names for boys and girls, along with the exact number of babies with those names. So the database consists in 2 separate tables. The most common one, national names, uses the field ID with a primary key and 4 additional columns, name, year, gender, and count. Using this information, this table holds people born in a specific year, with a specific name and gender of number of babies. The other table, called state names, is a more detailed table that looks at each state individually, so that it has the same columns as the previous one, and with addition of the state column. Next, it was implemented in Node.js with TypeScript using a clean architecture that contains the aforementioned structure in the architecture section. The logic implemented to manipulate the data stored in the database query in Mongodb need to pass an object with name, state, gender, and year. Will be the parameters to send to the API. However, this way will not always have all the values, because who is consuming may want to filter by name or state or gender or year. So it could happen that a call to API by name and the rest will be undefined. To solve this problem, it was created a Mongodb query builder function that takes the argument, the parameters of the object that need to be returned if there is a valid value within parameters. It is clear that this basically builds a query according to the parameters sent to the API, building an object with only valid values in an asynchronous function, which takes as parameter baby name type of type array, where the filters are those of Mongo Query Builder, and this MongoDB Query Builder is a helper function to assemble an object and return the 5 most commonly used names according to the mandated filters. On the front-end side, the query will be assembled in steps on different screens and uses the following logic. Then, when the user presses to go to the next screen, make sure to save the type or null and go on. The application was also developed with an offline concept. In the project, a class called Kiwi and another called Node were implemented. Therefore, the Node class makes requests to Kiwi where it has a validation if it is online or not. If it is offline in the Kiwi class, the request will be on hold. Once it is online, the pending request will be executed. Another important point is predicting the future popular names. To do this, Linear regression is used a supervised machine learning algorithm used to estimate the value of something based on a series of the historical data. So, by looking at the past, you can predict the future. The algorithm is run on a small 5-year data segment for each name. The regression coefficients for each segment are then combined to create a trend matrix. This allows to track the profile of each name against its matrix. Conclusion. The baby name application showed the user the 5 most popular names based on the desired filters. By this, we discussed the clean architecture and 3-tier implementation. It also describes a logical decision to visualize popular names. The main lesson is that the information visualization tools are not used as a tool, as a part of an online social environment. In other words, to design a successful data analysis tool, a good strategy is to create a system that's allowed for social data analysis. Thank you.